Hi, Assalamualaikum warahmatullah. How are everybody today? Hopefully everybody is fine, is doing very well, um, enjoying bulan Ramadan, enjoying the fasting month, enjoying reading Quran, watching majlis ilmu, internet, okay, and hopefully everybody you can is praying taraweh every night. Okay, so today we will continue our online class, Datacom. The next chapter, chapter 3. Okay, so we will see this, we will use this nota. Okay, chapter 3, OSI 7 layers principles for data communication and network. So this topic, this chapter, there are 4 subtopics. The first is 3.1, layer by layer protocols, principle and architecture, data communication interface and networking, data segmentation and reassembly, and the last subtopic in this chapter is error detection and correction. Okay. Okay, if you have the notes, you can watch outside this video here. Okay. So anyway, this nota is belong to Sir Hisham. So thank you for him, because this is the last semester's notes. Okay. Subtopic 3.1, layer by layer protocols, principle and architecture. Okay, for introduction, OSI or ISO. The layering model is OSI, which stands for Open System Interconnection. Okay, OSI, this one. The organization that developed the model is known as ISO, which stands for International Organization for Standardization. Okay, so in America, we have American National Standards Institute, ANSI. ANSI farms out much of the hardware standardization to IEEE. So this is extra information. So this is the website for ISO. You can go and find out yourself. ISO is an independent, non-governmental international organization with a membership of 164 national standard bodies. So national standard bodies ni salah satunya ialah SIRIM lah, SIRIM. For Malaysia, we have SIRIM. Okay. This is the national standard bodies. Okay, layer names and number of layers in the literature. So there are a few types of literature model, few types of model in the literature. They call it internet model, TCP/IP protocol suite, TCP/IP 5-layer reference model, TCP/IP model, TCP/IP 5-layer reference model, ARPANET reference model, and OSI model. So this is what we are going to discuss in this chapter. For this subject, we will follow this OSI model, Open System Interconnection model. So in this this model, they have 7 layers. 1, 7 layers. Okay, yes, 7 layers. 1, application. 2, presentation. 3, session. 4, transport. 5, network. 6, data link, and 7, physical. Okay. Okay. Anyway, they count it from the bottom. They count it from the bottom. So basically, first is physical, second is data link, third is network, 4 is transport, 5 is session, 6 is presentation, and 7 is applications. Okay. So what is the meaning of open and proprietary? Proprietary. Okay. They call it open source or open versus proprietary or private. Okay. Open meaning specification are public. Requires committee agreement. So it can be very slow to produce open open standard. Okay. Number 2 is proprietary, which is privately owned and controlled. Specifications are kept private so that other companies cannot duplicate. So this is privately owned by companies. For example, each company has their own standard. Okay, the company like the computer company like HP, Dell, macam-macam lah semua company tu. Apa ni? Komputer apa ni? Asus. Each company has their own proprietary standard. Okay. No outside agreement needed so that it can be very fast. It can be reactive to the market. Okay. Consumers prefer open and standardized system, as this allow them to use the product of various manufacturers. But sometimes it take too long to come up with open and standardized system. So you dapat proprietary lah. Okay. Layering and interfacing. Layering is an important concept in computing. When a user runs an application, the user interface with application. Application ni macam ni lah, macam software kita ni kan. Software kita dekat komputer. Microsoft Word, ni PDF, Adobe. Okay. The application interface with operating system. Operating system ni Microsoft lah, Windows. The operating system interface with BIOS. BIOS is the basic input-output, apa ni, standard input-output lah. Okay, ni macam microprocessor lah, microprocessor. The BIOS interface with the input-output hardware. So BIOS akan interface dengan hardware input-output, macam keyboard, macam mouse. Okay. To what purpose? The user need only know something about the application. It doesn't need to know any details about the operating system, BIOS or hardware. So you just use the application, the apps, the what we call it here. The application lah. Okay. So you don't need to know about any hardware. Similarly, the application needs information about the user and the OS, operating system, but not the BIOS or hardware. For layering to be successful, there must be standard interface into a layer. The operating system is said to provide an application programming interface, API. more than just a way of thinking about it. These layers can be seen in the industry. These layers can be seen in industry. Okay, so layers tadi tu. So some companies are specializing in hardware. For example, Seagate, Maxtor, Western Digital ini ialah hard disk, right? Hard disk. Some companies are specialized in BIOS. For example, AMI, Phoenix. Some companies are specializing in OS. For example, Microsoft Windows, Sun Open System. Some companies uh, are specializing in application or software. So Oracle, Microsoft, AOL, apa benda ni? American Online ke? Okay, so you can see this specialization of the companies are representing the layers somehow in the computer system. Communication layering. The communication between two or more users on the network similarly is broken down into layers. A possible model for this layering was laid out by the ISO, International Organization for Standardization. Okay. So what is OSI? Kita tengok tadi kan. OSI serve as a reference model. What is OSI? OSI serve as a reference model for how information is transmitted between any two points in a network. It guides manufacturers, or also known as vendors, so that they can make products that will work with other products. The OSI model is comprised of 7 layers. Okay, kita tengok ni 7 layers that are involved in communicating between two nodes of a network, two nodes in a network. So the 7 layers. OSI model was never adopted as a rigorous set of specification. The lower layer, okay, lower layer tadi kita katakan start from physical kan, start from the bottom. The lower layers, physical, data link, network and transport. The 4 lower layers, physical, data link, network and transport are the most part for the most part adhered to. Recall, however, that we have already mentioned a router which serve as both bridge, data link layer, and router, network layer. Router, okay, router is bridge plus router, router. Okay, what OSI purposes? Even if manufacturers do not restrict themselves to a particular OSI layer, they usually think of and describe their products in relationship to the OSI model. It provides a language and framework for discussion of network, so it persists and continues to be taught. Okay. So tadi kita ada jadual tadi, kita bincang berkenaan dengan TCP/IP model. Ini model yang agak lama. So another model for understanding communication network is through a TCP/IP model. It also broken into layers. It has no equivalent of OSI model's physical layer. The next 3 layers of the OSI model and TCP/IP model are roughly equivalent. Okay. The top 3 layers of OSI model are combined into 1 layer in the TCP/IP model. Okay, dia cerita apa tu? Tengok ni benda ni. So ni OSI model. So ini ialah TCP/IP model yang ni. Jadi kata yang 3 bawah ni hampir sama kan. Physical here, data link here, internet here, network here. So transport, see, transport sama. So 1, 2, 3, 4. Yang atas ni dia ada satu je, dia panggil application. Padahal dekat OSI dia ada 3. Session, presentation and application. Okay, so itulah yang dibincangkan tadi dalam nota tu. Okay. The main idea, the communication between computers can be broken down into layers. Each layer is characterized by its function and how it interfaces with the action level. Within the sources computer and starting at the user level, the communication is passed down through the layers to the lowest layer where it is sent through some transmission medium. The main idea, the communication travels at the lowest layer, physical layer. So physical layer is the lowest layer. Remember, the communication travels at the lowest physical layer, occasionally rising up to the second layer, the bridge, or data link, or third layer, router, until it reaches the destination. The communication now passes up through the layers. Okay. So these are the 7 OSI layers, OSI model, the 7 layers of OSI model. Kita bilang daripada bawah. 1, 2, 1 is physical, 2 is data link, 3rd is network, 4th is transport, 5th is session, 6th is presentation, and 7 is application layers. Okay, kita akan discuss further untuk these layers, 7 layers. Okay, the layers are realized by a combination of operating system, applications, for instance a browser, network protocols such as TCP/IP, and the software and hardware that actually place a physical signal onto a transmission line, an IC, modem, etc. Don't confuse TCP/IP, the stack model, with layers protocol TCP layer 4 and IP layer 3. OSI, network or computer. The transport layer can be viewed as a division between the computer and the network. The lowest 3 layers, physical, data link and network. Okay, always remember lowest 3 layers in OSI model, which is physical, data link and network, deal with a best effort to get information to the desired computer. The transport layer verifies the effort and hides the network from the layers above. The remaining layers treat the data as it was local. Okay, first layer. Layer number 1, which is physical, the bottom layer, the lowest layer, physical layer. Okay. There is no interpretation at this level. A stream of ones and zeros are put into a form convenient for transmission. Waves with little regard to their information content are sent and received. This layer is the most hardware oriented. It includes specification about NIC card, network card, types and length of cable, voltage characteristic, range level, age, etc. etc. Okay, so these are the physical layer, layer number 1. The physical layer involves protocols for actual transmission. For example, for Ethernet, for FDDI, RS232, and also ATM. These protocols also involve the interface with the next higher level layer. So dia paling bawah. So this protocol also deal with the interfacing with the next upper layer, which is data link. Okay. So the second layer is known as the data link layer. Okay. This is the second layer. At this stage, at this layer, one begins to consider bytes instead of just bits. Okay, so ada beza ni. Bytes instead of just bits. One examines some of the information content of the signal, at least the address and some of the error detection sequencing. Recall that bridges operate at this level. They know where a packet is headed. They know whether or not it has been involved in collision. And bit stuffing occurs at this level. Bit stuffing, nanti kita akan tengok apa dia bit stuffing. So kita ada data train. Ini kita letak bit stuff. Kita masukkan stuff. Okay, stuff ni macam sorok lada lah. Lada kita masukkan isi dia. Sama ada ini ialah end bit or end bit, kadang start bit. Okay, bit stuffing. Data packets are encoded and decoded into bits. It directs packets and handles error from the physical layer. It handles synchronization, timing. It must know where one bit ends and the next one begins. It should know where the bits finish and where the bit starts. It must know where the one byte ends. So tadi one bit ni one byte. And the next one begins. So one byte lah, yang ni bit. Okay. So in data links there are sub layers. Okay. Data link sub layers. There are two sub layers. The data link layer is divided into two sub layers. Dia panggil layer sub layer. The first one is known as MAC, MAC, Media Access Control Sub Layer. One is MAC. The second one is LLC, Logical Link Control. So what are these? The MAC or Media Access Control Sublayer takes the signal from or puts the signal onto the transmission line, touches physical layer. On the other hand, the LLC, known as Logical Link Control Sublayer, starts to interpret the signal as data, includes timing or synchronization and error checking. So that are two sublayers in data link layer, second layer of OSI model. Okay, layer number 3 is known as the network layer. The router acted at this layer. One of the main functions of the layer is routing. Store and forward are network layer functions. In a connection-oriented scheme, the virtual circle is established at the network layer, building the routing tables, troubleshooting the routing tables when there is a lot of traffic or if a connection goes down. The network layer also gathers related packets, packet sequencing. Okay, layer number 4, transport layer. As stated before, layer 4 is the dividing line between intercomputer transaction and intra-computer transaction. Apa ni? Intercomputer, intra-computer. So layer 4 ni is the middle of 7 layers. Layer 4 manage end-to-end verification. The lower layers make a best effort, but if data is lost, so be it. Layer 4 must ensure that the information was received intact. It does a higher order error checking. The transfer should be transparent. The higher layers do not know the data coming from another computer. So whose job is it? At a node layer 3, collects associated packets. If one was dropped, it may throw them all away. It is the responsibility of the sources layer 4 to look for some acknowledgement that all packets arrive. If no acknowledgement is received, it should retransmit. Okay. Layer 5, the session layer. The session layer, recall when discussing connection-oriented scheme, we mentioned the idea of a session. It is an agreement between a source and destination to communicate. This layer establish, manage, and terminate sessions between applications. They could be on the same computer or different computer. Okay, layer number 6, the presentation layer. This layer provides independence from differences in data representation, for example, encryption, by translating from application to network format and vice versa. The presentation layer works to transform data into the form that the application layer can accept. This layer formats and encrypts data to be sent across a network, providing freedom from compatibility problems. It is sometimes called syntax layer. Okay, so this is another name for layer 6. Presentation layer or syntax layer. Okay, the last one, last but not least, the 7th layer. Layer number 7 is known as the application layer. This layer supports application and end user processes. End user, so kita deal dengan applications. Communications partner are identified. Quality of service is identified. User authentication and privacy are considered. And any constraints on data syntax are also identified. The application layer, everything at this layer is application specific. Okay. This layer provides application services for file transfers, email, and other network software services. Telnet, apa benda ni? Telnet and FTP, file transfer protocol, are applications that exist entirely in the application level. These are not applications like Word and Excel, but services for such application. Okay, finish part 3.1. So that's all for this video. We will continue our next sub chapter 3.2 in the next video. Okay, so that's all for now. We will meet again in the next video. Until then, thank you very much for your attention during my class. So till we meet again, bye bye. Assalamualaikum warahmatullahi.